about comparing Axon Server and MongoDB. I think we've got everybody here. We'll just get started and kind of walk through things. So thanks for coming. Quick agenda. We're going to just do an introduction to myself. Who am I? Review kind of the building blocks for messaging-centric applications, because the reality is choosing an event store isn't just about storing events. You've got a lot of other things. If you're going to build an application that is going to scale up, scale out over time, there's other considerations, and this really comes down to infrastructure. Event store is a big component, but it's one of the few choices you have to make along the way. We'll talk a little bit about performance and storage between Axon Server and MongoDB. Talk about scaling out your application, management and monitoring. We'll kind of review a few pieces here, what capabilities each one has. And then we're going to give a demonstration of migrating from MongoDB to Axon. We'll run the migration tool, and then we'll just review things after that. Kind of review what we have and answer any questions that maybe I can answer at that point. So, all right. So a quick introduction about myself. My name is Ben Runshie, Solutions Architect with Axonic. I've been doing event-driven systems, event-driven services for about 20 years. I started way back working on just what was called enterprise application integration, where we would take data from one system and just push it into another. That evolved into business process automation. And then now in the last, I don't know, 5 to 7 years, 8 years, been working on systems that are more based on CQRS and event sourcing, as that's given a more rich experience. I've been working with Axon Framework since 2017 and using Axon Server since 2019. My contact information, you can contact me via email, or if you want to reach out to me on LinkedIn, my address there. So, all right. So, like I said, we wanted to review kind of the building blocks. So the concept of an evolutionary architecture, how are you going to go from possibly an unstructured monolith or even a structured monolith to scaling that out as the demands of your system are growing over time? Hopefully you've got an application that has needs that are going to keep increasing, new customers, new features, new integrations, new products that or new features that need to be added to that product. So how are you able to take it from conception and evolve it over time to handle your growing needs of scaling different pieces up or out at that point in time? So how are you going to make that happen? A second piece that we need to think about is location transparency. If you are going to take that monolith and need to scale certain pieces independently of another, how are you going to make it so that you don't have to rewrite code, build new communication mechanisms to make that happen? What do you have under the hood that can provide you that location transparency, so that if you took the query model that you have and need to handle that in a separate process because the demands of producing it are that high, and you don't want it to impact other aspects of your application, how are you going to make that happen so that that application can still interact with the query model using a query bus to make things happen, or so it can still access that data without having to figure out how do I find it on the network? And then finally, the final building block are messages. So we talked about this many times here at Axonic. We have commands, events, and queries. So again, these are all things that we're going to need to scale up, scale out, handle in different manners as our system grows. So if we can use these message types as the cornerstone to do integration between the different components of our system, of our application solution, we're going to end up in a situation where we can grow and scale out without having to do lots of refactoring, things like that. So those are the big pieces. And what I'll do is I'm going to try to take each one of these and put them in the perspective of, if you're using MongoDB as an event store, or if you've chosen that versus Axon Server, what does that mean in terms of choices you have, what your infrastructure looks like, things like that. So this, again, like I said, it's not just a simple choice of, hey, I'm going to run MongoDB as my event store, and it's, you know, a one-to-one comparison with Axon Server, because they're just not the same products. So you're having, by choosing one, you are deciding to need to have to include other pieces of infrastructure to continue to grow your system. So, all right. So we'll just start looking at events from an event perspective. So we have the event store overview. So the two products we're talking about here today, Axon Server provides a database purpose-built as an event store as part of the product. One of the big things that it also has that works very nice is a global incrementing counter to know where in your event stream a given event is. And it gives a consistent ordering of events for everybody who would be reading them. They're going to get it in the same manner every time. And finally, one of the big aspects that Axon Server provides as an event store is it can push events as they arrive in the event store to interested event processors. So this allows for increased performance because the event processor is not having to constantly pull Axon Server to find events. Rather, Axon Server is delivering them to the event processors. MongoDB, again, this is not built as a event store as its main purpose. This event store functionality is enabled through the use of the Axon Mongo extension. This extension provides two strategies for how we store the document per event, which is recommended because it probably produces data that is easiest to consume and troubleshoot and look through because each event gets its own document in the database. Or document per commit. This is where all events are placed inside of one document and stored at that time. The document per commit is probably not needed as much now since Mongo supports the idea or the concept of transactions now in more recent versions, since probably 2018, I think, roughly. So these two were put in place really to handle some compensate for the lack of transactions in Mongo back when it was released. MongoDB, if it's your event store, it's going to use a timestamp that's generated on the client as its way to order events. So we don't have the opportunity of a global index to know where in the event stream a given event is. It's all based on the timestamp that the client generated. So this has some risks to it. If your server or the node that you're running on, with somehow the system clock gets out of sync, you can end up with timestamps that are wildly out of place, possibly behind, things like that, which can lead to some problems over time, where as you're processing your event stream, you're going to miss events because they might show up behind when you're processing events where you think you're at, or where you last were at with the token. And we'll talk about that in a little bit. So the other piece here is event store performance. Digital Frontiers did a great job of putting together some benchmarks on this between Axon, Mongo, and Postgres. So we'll just take a look at that document here and review kind of what they found. So you can see, started off with all three different machines that they ran it on here. So a small virtual server, beefy, and the bare metal, and a dev machine, which is still a pretty good machine in my opinion. The application, pretty simple application, producing an event, storing it to the event store. All right, so let's move on to talk about, just to give you an idea of how Mongo does compare against Postgres. So Mongo is drastically faster than Postgres. I mean, probably has a bigger performance drop, as you notice here from this graph, over time than Postgres, but it's still beating Postgres by a wide margin. versus Axon Server, which has this, and this is really the biggest thing. It's the consistent performance over time. That's really what we're looking for out of an event store, because honestly, if this is an application that's been going to be around for a while and has value, it's probably going to have many millions of events that will have passed through it. How do you manage those events over time? That's something we'll get to. But what we want to point out here is that from a consistency perspective, the performance of Axon Server does not degrade over time. And I don't really want to talk about that one performs better than the other, because the reality is I could keep throwing lots of memory and hardware at Mongo, and I can get it to perform at levels that would be consistent with Axon Server. But the challenge is, can I keep it going there over a long period of time? As the amount of data that you're storing on disk increases, and we'll get to that, and the need to keep indexes in memory is growing over time, this starts to impact things quite a bit from a Mongo perspective. Whereas Axon Server, the way that it is storing indexes in memory and able to use the write-only method while it's processing, so it just knows, hey, I just need to append it to the next one, the next one, the next one. It doesn't have to do updates as part of its main processing. We'll get into some event store migrations, or transformations a little bit later, because there are situations where maybe we need to change an event store or change data in our event store, but that's not its main job. Its main job is to append an event to the next point in the stream, and it does a great job at that. And that's really what we're after here. All right, so we'll get back to things. So the one thing that we did not get out of the Digital Frontiers performance document or performance benchmark was how much Mongo takes in terms of disk space to be able to store the same number of events as Axon. This is about a 4-to-1 from what we ran here. Took us just slightly over 100 gig to be able to store those 100 million events, and these are pretty simple events. It's just I was following the gift card example, or gift card concept is what the code that Digital Frontiers used to produce their data, and it just basically issued a gift card is what it is. So it was a very small JSON document that had just 2 properties inside of it. So as we stored this in Mongo versus Axon, the difference is pretty drastic in terms of storage space. So this is one of those things that over time, this is 100 million events. You could end up with 200 million events, 300 million events, 400 at that point, you're starting to put up quite a bit of disk space in place. And then these are also pretty small events. So if your events get bigger, these numbers are going to be even that much more amplified for how much it's going to cost to run things, run your solution using MongoDB as the event store. And chances are you're going to want all of your events that you're using that are the recent ones to be running on SSDs. So you're probably looking for pretty fast, high performance disks to be able to make this your application scale. So again, the cost of running things goes up quite a bit as a result of the storage space that's required. All right. So at the end of thinking about Axon Server versus Mongo, just from the event store perspective, we want to think about, hey, what does this look like from an infrastructure view? At this point, it's pretty easy. It's just Axon Server. Our application's connecting to it. It's doing the things it needs. No real problems at this point in time. Easy to manage between the two. MongoDB looks very much the same because all we're using is the event store at this point. We're not having to scale up anything from a event processor perspective or a query perspective or command handling perspective just yet. So let's move on to what it means to handle events, do the event processing and distribution of them when we compare the two. So Axon Server Uses the push models we spoke about earlier to deliver events to the event processors. This allows our events to be processed more quickly. Reduced I/O on the server because it just has to write it to disk and then push it out to all the connected consumers that are connected to that context at that point. The event processors are able to use that global index to track where they're at in the event stream. So it's real easy to tell where they're at. Don't have to have any lookback windows because of timestamps involved, those types of things. MongoDB. So here, event processors have to poll MongoDB to retrieve events for processing. So this adds additional load on the server. As you notice here, we talk about, hey, recommending you should use the secondary nodes to perform these reads, because then the primary, which is trying to accept all of the events in the first place, can do that job with less impact. But there's this lookback window that's used when we're doing this from event with MongoDB, because the timestamp that is the index that's being used as the index of where an event is in the event stream. As things get written, maybe we ended up getting ahead. So we always, or if we don't see a given event because of replication to the secondary nodes. So what we need to do is have a look back window that's saying, hey, I know I was at this point in time, but let's go see if there's anything that's 1 second behind in case it just got replicated to a secondary and I can now find it. So we always have this look back window going on. And this works pretty well, except in cases, like I said, where, hey, we had a timestamp issue because one of the nodes that is producing events, when it's doing the command handling, its system time got out of sync. So it could be that an event gets written, but it's just slightly over 1 second behind. At that point, you're going to miss it. So you're going to have to, as your system grows, and any performance issues that might also impact how quickly replication can occur between one area to another, between your primary and secondaries, that can also impact how far into the future you've already processed something if you're reading from one node that it has fallen behind. So again, and that's another thing, the speed with which, or the timeliness of processing events is going to be possibly impacted by replication. If you have a situation where you are sending tons of events to MongoDB, the primary and the secondaries are going to be spending a lot of time trying to replicate these events with one another. And if one of the secondaries were to fall behind, you're not going to see those events as quickly as you would in the push scenario that Axon Server uses. So scaling up is, a constant need, as you would have either bursts of activity that can impact replication, or just in general, as the amount of data you have to replicate over time continues to grow. You could also use another piece of infrastructure to distribute events. So maybe then you only have one event processor or just a couple that are making this happen for yourself. So you could send it to Kafka or RabbitMQ, but it doesn't. So this would absolve the load on MongoDB, but it doesn't absolve the need to still use the polling model, because that's the only way we can get data out of MongoDB when it's your event store. So if we go down this path, we see Axon Server, we're able to scale out our event processors. And hey, we still love MongoDB as our spot to store our projections. It's real easy to define things. Don't have to deal with as many ORM issues possibly. And it's just a great product for that. So we love using it for that. If we're running MongoDB, we've decided to possibly use Kafka to really do more event distribution so that we're able to avoid going after MongoDB as event store for event replays, things like that. People would use Kafka instead, possibly. We now have two pieces of infrastructure that we're running at this point, MongoDB and Kafka. Or if you're just putting things back into MongoDB as projections, you don't have that extra piece of infrastructure. But another thing to consider, One other thing, we do have a Kafka extension that allows for this to happen, or that makes this a lot easier. You can check that out. It's on our GitHub Axon Framework GitHub repository. So again, but every piece of infrastructure adds that much more complexity to what you're doing. You might have experience running both of these in other situations, but it's just still more that your application itself needs to keep track of. The next thing we're going to talk about is command handling. So if we want to scale out, we're going to need a distributed command bus. So we're going to need this so that because as the load on our system increases, if we are running command handling and event processing, both in the same, or query handling, all in the same JVM or application, we're going to become thread bound by this. And the distributed command bus is the easiest way for us to offload that and be able to scale up, scale out, run thing. Maybe you want to have certain commands handled by certain nodes that are heavier duty. Maybe they run less, but you want to make sure they get handled in their own process. This gives you that opportunity to scale things out. You're also going to need intelligent command routing. So when you get a command for the same two commands for the same aggregate, we need those to be routed to the same node so that we can avoid any concurrency issues when saving our events. So really what we want to do is avoid having two events for the same aggregate ending up with the same sequence number. We want them to be processed in order. This also lets us leverage aggregate caching so that we aren't having to go back to the event store constantly to say, oh, go get me all the events for this aggregate. Get me all the events for this aggregate. That can reduce the load on our event store quite a bit as well if we set that up properly. So command handling with Axon Server. Axon Server provides us a distributed command handling out of the box. The Axon Server command bus does this for us. It out of the box intelligently routes those commands like we talked about. It'll do load balancing to make sure that one node is not getting more than another, if it's possible. If you only have the command available in one node, there's nothing to load balance across, but it is able to at least route it there. So consistently. All right. So if we're using MongoDB, again, MongoDB doesn't offer anything to support this distributed command handling. The Axon Mongo extension does not offer anything. So what you're end up having to do here is use the Axon Spring Cloud extension. This is an extension that would run at the framework level. So again, back in the application, it isn't anything that MongoDB is going to be able to do for you. So what you're going to end up doing is being able to run a distributed command bus using Eureka, which is the Spring Cloud Netflix discovery mechanism. So you're going to have to start up a Eureka server, and you're probably going to want to be highly available. So you're going to need 2 or more of these, probably sitting behind some sort of a load balancer, so that you have some high availability. So if one goes down, you still have another one up and running. So then in your application, you take a dependency on the Eureka client and connect to those Eureka servers, and then the Axon Spring Cloud extension will then manage when you use the command bus or the distributed command bus to determine, hey, which of the nodes is handling this particular aggregate, or which of the nodes handles this particular command, and it'll distribute those to the proper node. This does not do load balancing to the same degree as what Axon Server will do. And it also doesn't completely eliminate our concurrency issues. So if nodes go offline and come back, it takes time for it to become known to all other nodes. All the work to keep track of which command or which aggregate is being handled on which node. You could run into situations that's synced at the time of heartbeat. So you could find that you accidentally do have a command handled for a given aggregate on 2 different nodes at the same time, and you run into the concurrency issue that we're trying to avoid. So you'll still get that error. So it won't store to the event store, but you're going to have to retry that, and hopefully the one you wanted to handle first is in there, got handled first. And then finally, if nodes have connection errors, that node's blacklisted. So now you're down a node. So what does this mean in terms of being able to truly be highly available? So there's a lot of considerations to take into place if you're running things at scale here. If your volumes are lower, things that, obviously these issues don't manifest themselves as quickly, but it's still issues you could run into. So I've got a few links here. We'll send these slides out at the end so you can get all these links. So there's just the link to the repo for the extension, and then there's a sample showing how you could set this up. That's in another repo that we have. So after we're done with this, done talking about command handling, if we're using Axon Server, we've broken out our command handlers, and now and we can send commands to Axon Server, who is going to then send them on to the command handler. And we're still doing this with just the same amount of infrastructure as we were before. So with Axon Server, we get this distributed command bus that solves our problems. Because we chose it as the event store, we get these other things coming along for the ride. We don't have to put more effort into getting something stood up. Whereas if we're running without using MongoDB as the event store, we're going to have to stand up a Eureka server, 2 of them, like I said, probably put it behind a load balancer, more infrastructure that's required to make things happen. And then our applications are going to have to make sure that they are connecting to that Eureka server using the extension, and so that they can do their command distribution between whichever node is handling that given command or that given aggregate or that given command. Query handling. This is the final message type that we talked about earlier. Again, we're going to need to scale out query handling as the load on our system increases. This is, again, something that, IO being what it is, we'd like to push that off, have it handled out of band, and then send back the response to send back to the client. Or maybe we have the need of wanting to subscribe to changes as they happen over time using subscription queries. So MongoDB provides no support for distributed query bus. And Axon Framework has no other distributed query bus providers available except for Axon Server. So again, then we'll move on to Axon Server. Axon Server, as stated, provides the only distributed query bus that we can have. So at this point, we have now just run into a limit of what we can do to scale out queries if we've chosen Axon DB as the event store to make that happen. You could always run Axon Server side by side with MongoDB to get you that distributed query bus. That's probably the choice you're going to be pushed to here if this is the case. So now you would have possibly another piece of infrastructure. But the reality is that those are the types of choices. There's nothing that we can get out of the box or another piece of infrastructure that we can just add to complement MongoDB outside of using Axon Server. So again, we go back to our current architecture. Hey, we've been able to distribute out our query handlers. Our API now is just handling requests. That this could be reading off of a queue, HTTP requests, whatever have you, sending them to Axon Server, and it's able to, send queries to Axon Server to be intelligently routed, commands to be out there, and then again, our event processors are running nicely. Running off of Axon Server as well. And as we talked about, here's the current architecture with Mongo. There's no change at this point. We don't have the ability to distribute queries in any way, shape, or form unless we were to take on Axon Server as another piece of infrastructure in this picture. That would be the only way we'd be able to make this happen. All right. So now we'll get into some management pieces. Just because there's more to running an event store than just storing events. You have to be able to archive, manage those events over time. Maybe you have events that you want to move on from. You possibly are going to run into situations where you need to make a change to your events. This was an area where something like MongoDB or a SQL database had an edge over Axon Server. We've added a few things to Axon Server to help you in certain situations. And then we'll talk about what monitoring options you have to monitor the two event stores. So if we go down event archiving, Axon Server has tiered storage and the concept of secondary nodes. So tiered storage is just going to be taking events and pushing them as they age onto cheaper disks over time. So each node that you have that keeps that is participating with a given context where you have set up this tiered storage for is going to be handling these independently. So they'll each keep pushing those events that they have locally in their copy of it onto that cheaper storage over time. So so you're not reducing the number of events, but rather you're able to save money on what it costs to store these events over time. Secondary nodes, this is a different situation where rather than just storing the same event and pushing it onto cheaper disks, what this will do is once those events pass the threshold of whatever time configuration you have set up, those will get moved over to a secondary node. And once they are confirmed to be there, they're going to be removed from the primary node, so that the primary node is only keeping the most recent events. This is going to help keep, again, your disk costs down, and possibly your performance at a consistent level all the time, because you haven't crossed that threshold as much for how much data you have on that one given node. The other thing is it's going to keep your management of how much data, how much disk space you need available. Maybe it's going to keep that a little bit more consistent. You're not going to have to grow that over time, and you're just going to be pushing it onto another server, and you can decide how you want to store it in terms of what performance of those disks you want over time. MongoDB, if you're using Atlas, hey, they've got an online archive. This has you can either use a date field or a custom query. Date field works really well for documents that are events because, hey, that timestamp is there that we spoke about earlier. Or you can have a custom query. The custom query is a little more unique. It could be that you go look for the presence of a given event that says, hey, something was closed. And maybe that means at that point, once it then is closed for 30 days, maybe you can take all events about that given aggregate and move them over to grab them and have the online archive push those over to the other database. So it does move the documents to another database. So in this case, you're keeping the amount of data you have in your event store at possibly a consistent level to give you some consistent performance. But again, you're still storing data at another spot too, so that the overall costs are not reduced in terms of total storage space. If you're running it on-prem, there's nothing out of the box available that I'm aware of. But a lot of people can typically set up a job to perform this task, and you can then move it just as the online archive would to another database, or you could possibly move it to S3 or some other storage mechanism at that point if you wanted. Event transformations. Historically, Axon Server did not have anything that would allow you to modify an event once it was written to the event store. You would have had to do something along the lines of reading all the events with a processor, making whatever changes you wanted, and then turning that into a command and writing it to another context. That would be an approach, or just writing an event directly to the event store in a different context is what it would have had to be if you wanted to do this. So there'd be quite a bit of uplift, or quite a bit of overhead to make this happen. Now we provide an API to make this happen. Useful for scenarios like that I have listed here. Maybe you have a lot of upcasters and, hey, gosh, I'd like to stop having to run these every time. And you want to get to it just a consistent, hey, here's the version we're processing now. Things have stopped changing over time. I can throw away those upcasters and just get to a consistent state. Maybe you need to move to a new serialization format, or handle some serialization issues that maybe you ran into because the format you chose didn't have enough information in it to successfully get it done. And then also encrypting data. That's another one where maybe you put data into the database to begin with, and now you did it in a quick manner, and you realize, oh my gosh, that's data we need for whatever. Maybe you have some new requirements that came along about, or a new law was passed that requires these types of things. This would allow that to happen. So this is available starting in 2023.1, so this past year is when we released this. So it's now something that puts us up on par in terms of being able to modify your events in these in important situations, not just because you felt like it, because that's going to be going to be adding more complexity to your solution at that point if you do. MongoDB and every other SQL event store has always had this available to it, just because that's the way they work. They're built more with that in mind. So updating something document is what they've always had. So some monitoring options. Axon Server provides actuator endpoints. This allows you to check the status of each node, the context, how they're doing, how many commands are pending, how many queries are pending. Lets you manage the flow of information or flow of those commands being routed so that you're not overwhelming your command handlers or query handlers. Axon Server will buffer those for a period of time. There's also a Prometheus endpoint, which can be used in conjunction with Grafana, or it can be scraped and sent to what your, whatever your monitoring tool of choice is. There's a webinar for this. It's a couple years old, but it's still very pertinent, very, very relatable, very useful. And then there's a repository off the webinar that has a great example. And this repository does a great overview of what metrics are provided and what they mean and how to interpret them. MongoDB, again, you can obviously monitor MongoDB. It's got a great, it's got lots of all the standard things that a enterprise grade database would have. IOPS, all the disk things, all the things of, hey, how many times do we do reads versus writes, and where are the content, where's any issues at? But the thing it doesn't provide is this from the perspective of being an event store. So it's not able to tell you, hey, how many commands have been sent through my system here in the last few minutes? How many queries have been sent through my system here in the last few minutes? What's the event processing time to deliver those down to what's that lag that maybe you're incurring? Those are all things you have to go somewhere else to make that happen. They have to be done at the application level. We do have Axon Console that we'll have a link to at the end that helps you with this. And then I have a link here just because, just to get information on both sides, how to monitor MongoDB and what metrics to monitor. My experience in running MongoDB, the main metrics that I use, disk IOPS. So this is going to grow over time as the number of documents grows. It has to. More data on the disk means I probably have more work to find what I need off the disk. I'm going to need more IO to get that to happen. More volume, more clients connecting and sending events to disk. More event processors are going to cause this IOPS to go up. Swap usage, if this is going high, it's suggesting that, I'll get to your question here in just a minute. Let me finish this one slide. Swap usage, if it's high, it's suggesting that you've got a pretty big index that's not fitting in memory, and maybe there's some things you'd want to do to handle that. In other words, maybe archive some old events to keep the size of the index smaller. Different things, add more memory, hardware, scale up, those types of things. Replication is another one. You want to monitor replication lag and replication headroom. The lag, you want to make sure that your secondaries are not falling behind the primary by too much. If they fall too far behind, and we'll talk about that in the headroom piece, your ability to process events in a timely manner are going to be impacted. So If you have speed or you need to keep a particular view updated as fast as possible, that's going to be impacted. If you need to be able to push out things with subscription queries, that's going to be impacted. So these are all the issues that you're going to run into if the replication lag starts increasing. The headroom, so this is the difference between where the primary's op log is and the lag of the secondary node. So how far behind are you? So if you have a lot of headroom, like, hey, I've got 2 hours of headroom, maybe that's great. If you got 24 hours, 2 days, whatever it might be, the higher the value, the better. Means you've got lots of headroom to be able to handle things. If it goes to 0, meaning, hey, there's no headroom between where the primary is at and how far back the secondary is, that secondary is going to go offline and move into a recovering state. So this is something you really got to keep track of if you're running MongoDB at scale, and you're using the secondary nodes for a lot. If you're just running MongoDB in a replica set to give you that high availability for your projections, this is probably less of an issue because you're probably not reading and writing to projections, or you're not reading projections at the same rate that you might be writing to a projection, for example. The need to query is probably not keeping up exactly with every one of your projections that you're building. So let's see, is an API for modifications of events in Axon Server available for on-premise instances? Yeah. So these are all available. It's just a product that comes, or a feature that comes with Axon Server in the 23.1 release. So if you run it locally, it's available to you there. So totally available. You don't have to be running things like with our cloud instance or anything like that. So, all right. So falling a little behind here. Sorry about all this. So migrating from Axon Server, or from MongoDB to Axon Server, you could do the reverse, I suppose. That's fine. We have a migration tool. I'm going to try to run it here real quick. It migrates events and snapshots, but it's not going to migrate your tracking tokens. So once you finish the migration, you're going to have to change. You're going to have to make some changes to your application. So you're going to have to change the event store over to be connecting to the instance of Axon Server or the cluster that you migrated to. You're going to want to back up those existing tracking tokens and then delete them from the tracking store. And I'm suggesting you back them up because if you have to go back in time, possibly you want them. So I'm not going to tell you to just blow them away with no regard. But hopefully you're always going to just be starting at the head of the stream. And then you're going to need to update your processor configurations to specify that the initial token should start from the head of the stream on restart. If you just blow them away, it should go there to begin with anyways, but it never hurts to tell it right away. I'm sorry, it would not. It will go back to the beginning of the stream, the tail of the stream, and start and reprocess all those events, which is not what you're looking to do. Sorry, I'm saying too many things here all at the same time. And I do have a demo for that we'll get to. But what I wanted to show you here was the code to set the initial token. So we want to create the head token. We want to be at the head of the stream, at the tip of it, so that we know we are picking up where we left off when we bring the system back online for processing, doing event processing. All right, let's give a shot at running our migration. So what I have is, I have an instance of MongoDB here that I've got set up that already has, I don't know what, 57,000 events in it. And then I've got an Axon server here that has nothing. This is just a simple standard edition one. So it just has the one context on it, the default context. So what we'll do is we'll take a look at the migration tool. So you can all see migrate secret password here to connect to MongoDB. So I'm going to tell it that the migration source is Mongo. Give it the connection to MongoDB. Since I'm just using a local Axon server, I don't need to specify anything about Axon server when I run this. So then we'll just kick it off here. Hopefully it runs, doing a demo. All right, looks like it's doing something. So let's take a look again here. Yep, and so it's starting to migrate everything over. So it's pretty simple. I obviously ran it just right in the IDE because it just made it easy enough to point this out, hit a button, do things. But if you just compiled it and gave it these parameters at runtime at that time, oh, sorry. Yep, share the entire window. Sorry. Is it going to? Sorry, can't share my. It's not letting me share the whole thing. Apologies. But you can see we had about 57,000 events that I had here in MongoDB. Let me see if I can share that one. There we go. So 57,465 when I ran it. And now we're at 57,464. So we'll have to figure out what happened to that last one at that point. But so we were able to push them over there that quick. Didn't take much time. It's pretty easy to run. So, all right. So let's get back to my presentation here. All right. So kind of in review, we want to talk about that if you're comparing Mongo to Axon Server, this is not just about event storage. That's maybe the jumping off point, that because you got to have an event store to do event sourcing. I mean, it's a need, and you're possibly not scaling your application up or out at that time. But you got to think about where you want to go with things, where you think your system is going to be a year from now, 2 years from now, and what you're going to need to make that happen. You got to think about location independence to make those things scale up, scale out over time. And you're going to need the ability to scale each message type. They all have different needs. What's that going to look like for you? If we go look at events in the event store, Axon Server provides that more consistent performance over time. Again, we can always buy up to get the same performance of anything. Kind of. Maybe there's some limitations to some things, like if you go back and look at the Digital Frontiers benchmarks, we're never quite able to get Postgres to perform at the same level as Axon Server. Disk space required, 25% less on Axon Server. So think of this as dollars over time. You start to get many, many events in your event store. What's that going to cost you? How are you going to manage that over time? Event management features. Axon Server has the tiered storage secondary nodes. So in other words, these are built right in. And we're going to continue to add features about how to manage events. You can see, I wouldn't be surprised to see us have some tiered storage level that goes out to S3 at some point, or I'm sorry, to blob storage, object storage to meet your needs. MongoDB, again, if you're using Atlas, they have an online feature on-premise. You've got to find some way to make that happen for yourself. Infrastructure needs. Mongo is going to require will require more infrastructure to scale out, whereas Axon Server provides all of the necessary infrastructure right out of the box, like we talked about. Monitoring, I'm not going to review it too much here because we've got some good slides, but suffice to say, Axon Server being purpose-built for an event store, you're going to get event store type monitoring available out of the box with it. MongoDB, you're not going to get it from a database perspective. You're going to have to go down to the application and only the application to get that. So that maybe isn't going to be able to give you that perspective of, hey, am I running, multiple event stores against MongoDB, right? Maybe I am. Maybe that's how you chose to run it. Well, is one hit impacting your performance versus the more than the other? How are you going to determine that type of thing? That you're left really determining that from just the database metrics that are available to you. And then migration. You have the ability to migrate, thinking of transformations of events. That's now something that's available inside of Axon Server. So you can at least migrate events from one format to another if you have those different needs, like maybe removing upcaster chains, or you need to now encrypt data, for example. And then finally, the migration to be able to go from MongoDB to Axon Server using our migration tool. So it's something that's pretty easy in terms of running the tool. There is the planning of, okay, now that I've moved over to Axon Server, how do I make this happen? Without downtime, can I afford downtime? How does that work? You're going to have to do some planning there. We do have the ability to just keep running the migration tool. So it's just going to keep tailing, go right after whatever is at the head of the event store all the time, to keep pushing it into Axon Server. And at some point, maybe you can bring things down in a rotating fashion that allows you to get some zero downtime. But this is something that it's going to be unique to every situation. So, all right. Well, we had the one question from Mad Behemoth. Anybody else have any questions at this time? If not, I mean, I'll keep talking and I'll keep looking in the question in the chat window. But if not, we will be sending these slides out at the end here. And then we also wanted to let you know about a few other resources we have. Our website, great resource for things. We have a podcast that talks about different things related to Axon, Axon Framework, Axon Server, and just CQRS event sourcing in general. We have a new product, Axonic Console, that I highly recommend you check out. It allows you to keep metrics or have metrics on how your applications are performing while they're processing events, handling commands. You can see bottlenecks. You can also see how your commands lead to events. Your events might lead to other commands, those types of things. Hang on. Excuse me. Axon Academy gives a great opportunity to learn about our tools and technologies. There's a few free courses. We have our reference guide. This is the documentation for our platform. And then, of course, if you have any questions for the larger community, Discuss is a great opportunity, is a great place to go to get those things, your questions answered. All right. So we'll move on to finally, we are going to be at Developer Week in February in San Francisco Bay Area. It's in Oakland, actually. If you have any interest in joining us, please contact my my partner Drew, who's been helping me out here today. He can get you some free open passes to come to Developer Week, and we'd love to see you there at our booth. So, all right. Well, if there's no other questions, I will end it on that. And thanks for joining us, and I hope you have a great day. Thanks. Bye.